Okay, today we were talking about probability, so this is on page 22. Do you all know what probability means? If I tell you a probability of something is, right, the chance of something happening. Probability is expressed as a fraction, a decimal, or a percent. Always between 0 and 1 when you're expressed as a decimal. So you would never say that you have a probability of 1.1. If I tell you that the probability of an event is 1, what does that mean? It's going to definitively happen. If I tell you that the probability is 0, what do you think that means?
It's not going to happen.
Not going to happen. If I asked you, what's the probability that you're going to have homework tonight?
100%.
100%. Normally we don't express probability as a percent, we express it as a decimal.
So it'd just be 1%.
So it just would be just 1, plain old 1. If I asked you, what's the probability that it's going to rain tomorrow? Take a guess.
0.
50?
35.
I would say maybe 0.5. 0.5, which would be 50%. Okay. These questions basically test how well you can read. So they look tricky, it's just a reading problem. So if we look at examples 1 to 5. A survey of 170 randomly selected teenagers aged 14 to 17 in the U.S. was conducted to gather data on summer employment of teenagers. The data are shown in the table. Okay, so 170 people total. They were broken up 2 ways. First, we know if they're 14 to 15 or 16 to 17, and whether they have a summer job or do not. Okay, what percent of those surveyed, so that means I'm looking at everyone surveyed, had a summer job? Okay, so we're going to start out with a fraction. Out of 170, how many people had a summer job? 59. Now, this is not what the question is asking for. The question is asking for a percent. So you're going to have to do 59 divided by 170.
35%.
Which is 0.347, about. So this is about 34.7%. I like to go to 3 decimal places. Okay, what is the probability of being 14 or 15 and having a summer job? Okay, so again, we are looking at all 170 people. Out of those 170, how many are 14 or 15 and have a summer job?
20.
20. Okay, a few different ways you can express your answer. First, you can express it as a simplified fraction. So if I divide both by 10, I'm going to get 2 out of 17. That's one possible answer. Second possible answer is as a decimal, which is 0.118, about. Lastly, you can express it as a percent. I'm not a big fan of that, so I won't do that, but technically it's not incorrect. Okay, question 3. If a random individual from the sample is chosen, so again, if we are looking at all 170 people, what is the probability that the individual is 14 or 15 and does not have a summer job? So who's that? 14 and 15 and doesn't have a summer job?
69.
69. Or is 16 and 17 and does have a summer job? So that should be 39. So this gives us 108 out of 170. Probability could be a fraction, decimal, percent if you really want to. I don't like the percent one though. So if you divide this in your calculator and hit math frac, simplified fraction is 54 over 85. If you want to divide it, it's 0.635. Again, you can also express it as a percent, although I won't do that. Did you all do this last year?
I think so.
In passing.
In passing, yeah, you didn't spend much time on it if you did it. Okay, here's why I say these questions are reading questions, is when we get to question like number 4. If a person is chosen at random from those who do not have a summer job, I'm no longer looking at everyone. I'm only looking at the people who don't have a summer job. How many people do not have a summer job? 111. Out of those 111, how many are 16 and 17? 42. And then example 5. If a person is chosen at random from those who are 14 and 15. How many people are 14 and 15? 89. What is the probability that the person does have a summer job? 20. Again, if you want to, you can also express that as a decimal, which is about 0.225. Questions on this page? Okay. What I would like you to do is move together with your group and do examples 6, 7, and 8, please.
That was the first one out, then I touched the cricket bat and I got yelled at.
You got about 15 seconds. Okay. We're going to go over this. We're going to do one more example together, and then you guys are going to try some. So if I were you, I wouldn't move. Example 6. What is the probability of being an underclassman and having a driver's license? Teo, what did you put in the denominator of your fraction?
In my fraction, I put 250.
Okay, and what did you put in the numerator? 89? Okay, everyone agree?
Yes.
Yes.
Okay, so the question here is, are we looking at only underclassmen or everyone? We are looking at everyone. So the denominator should be 600. Out of those 600, underclassmen that have a driver's license is 89. So I think that's one that you all tend to get wrong. I think many of you got that one wrong, which is okay. Example 7, if a person is chosen at random who does not have a driver's license, what is the probability that he or she is an upperclassman? Nathan, what did you put in the denominator?
I put 240, but I'm not so sure.
Okay, we'll help him out. Do you all agree with his 240?
Yeah.
I agree.
Nice job, Sam.
So we're looking at only people that don't have a driver's license. Nathan, out of those people who do not have a driver's license, how many of them are upperclassmen?
79.
79. Okay, if a person is chosen at random, who am I looking at?
Everybody.
Everyone. So out of 600, what is the probability that he or she is an underclassman with a driver's license? 89. Or an upperclassman without a driver's license? 79. Casey, what do you get when you add those two together?
What?
And then hopefully you simplified it. Now, fun fact, SAT doesn't care if you simplify. So, if you leave your answer like that on the SAT, they are fine with that. They don't care if you simplify any fractions. So, if I were you on the SAT, I just wouldn't simplify mine because they don't care. How did those go? What?
You might mess up simplifying.
Right, exactly. If you mess up simplifying, then you just lost that point.
Yeah.
Okay, question 9. This is going to be the hardest one that we do today. Data was collected on ice cream flavor preference for a group of freshman and sophomore students at PHS. The partial data table is shown at the right. Okay, so first thing that we know, before we keep reading, 120 people liked chocolate, 90 people liked vanilla. There are 2 times as many freshmen that prefer chocolate as there are freshmen that prefer vanilla. There are equal number of sophomores who prefer chocolate as vanilla. If a student is chosen at random, what is the probability that the student is a freshman that prefers chocolate? Okay, so we need to fill out this table before we can answer the question. There are 2 times as many freshmen that prefer chocolate as there are freshmen that prefer vanilla. Miranda.
So the way I did it
Okay.
is that I looked at the amount that,
No, keep going.
which is 90, and I know that 30, and then I know that that since there's an equal amount of sophomores for that, sorry, I'm just kind of confused.
Did you do a little guess and check?
Yes.
That's kind of what it sounded like.
Yeah.
That works. I'm going to do it a different way, though. It does not involve guess and check. Josie? Pause right there. Let me go with that, and then we'll come back. Okay, so what she said is a good start. 2 times as many that prefer chocolate as prefer vanilla. If we call X to be the number of students that prefer vanilla, then twice as many prefer chocolate, that's a 2X. The next thing Josie said is, if there's an equal number of sophomores who prefer chocolate and vanilla, she did Y and Y. Now here's my question for you. Can I use X and X here instead of Y and Y? Why not? Let's see if we did X and X instead. If we did X and X instead of the Y and Y, what is that saying? Look at these two. That the same number of freshmen and sophomores prefer vanilla. So what she said with the Y and the Y, that was good. Now, if we have 2 variables to solve for, how many equations are we going to need? 2. Josie, what are your 2 equations? Good, thank you. Okay, so we have to solve the system. Any suggestions?
Move. No. Elimination.
Okay, sure. Casey, elimination, what would you more specifically like to do?
I was just going to multiply the bottom by -2.
Okay, so let's multiply the bottom equation by -2. Why would he do that?
So that x is equal to.
Yeah, he wants to eliminate the x's. So this will be -2x minus 2y equals -180. So make sure you multiply the 90 by -2. If he did everything correctly, the x's should cancel, which they do. We get -y equals -60. So y equals 60. Okay, now let's be smart here. Do I need to go back to the system?
No.
I should be able to tell what x is right away. What's x now?
30.
30. 2x then is 60. Y and y is 60. If a student is chosen at random, so out of all 210 students, what is the probability that the student is a freshman that prefers chocolate? So 60 out of 210. Exactly. Okay, can you promise me that on your question on the homework like this that you're going to get it right?
Oh.
No. Okay, here's what we're going to do. This next page, you have the last 4 problems to do. So you are doing these with your group. When you are finished, let me know. I'm gonna give you guys another 2 minutes and then we'll go over. Okay, we are going to start going over. So if you guys can look up here. The table represents 50 movies that had the greatest ticket sales in 2012, blah, blah, blah. What proportion of movies are comedies with a PG-13 rating? Miranda.
A.
A. Okay, are we looking at all movies or just a subset of the movies?
All of them.
All movies. So all 50 movies. Out of those 50s, comedy with a PG-13 rating is 4, which they simplified. If a PG-13 movie is chosen at random, Lizzie, what goes in the denominator?
It would be 22.
22, right. Only PG-13 movies. What is the probability that it is an action movie? The numerator?
It would be
10, I agree. So you can simplify that to 5 out of 11 or a decimal. I don't know what the decimal is, though. What percentage of the movies are action movies? Renz, what did you get for that?
36%.
36%. Yes, a lot of you did 18 out of 50, which is good. Make sure, though, that you answer as a percentage, which would be 36%. Okay, last one, which I thought was a difficult one. In 2012, the total population of individuals in the U.S. who were between 14 and 17 was about 17 million. Do you guys know what inclusive means?
It's just them.
Including 14 and 17. If the survey results are used to estimate information about summer employment of teenagers across the country, which of the following is the best estimate of the total number of individuals between 16 and 17 years old? Maria, can you tell me your setup?
I did 39 over 170 equals X over 17 million.
Okay, so she's saying, if I look at the whole sample, 39 people are 16 to 17 and have a summer job. The reason she used the whole sample is 17 million is all teenagers between 14 and 17. So you're setting up a proportion. All teenagers between 14 and 17, teenagers in our sample between 14 and 17. And then you're going to cross multiply. You get X is 3.9. Remember that that's 3.9 million, though. Giving you an answer of B. How do we feel about probability?